back in the days with John Myers and myself, and we've had some pretty good reviews on some of the stories that we've told, and I got an old sweatshirt here. It's Jack Corpella size. You see that, Jack? Yep. It's a little bit schmedium, and I should be wearing a little bit schmalarger. Hey, Mark again. Roger, what's up? I want to tell y'all hey, Tanner. I want to tell y'all about some history that we had that was really a great time with the late, great John Myers, which one thing that was funny was when we had this bike back in the day, history and stuff was, you can't buy it. No, this shirt, no, sir. Sorry. This shirt is not for sale. This is one and only. Sorry. And I confused everybody last week with the other really cool APE screen print I had on my shirt with the big John Myers World Champ, Pro Stock, all that stuff. Yeah, that was cool. But look, these things are priceless, man. They're irreplaceable. Hey, Randy. Hey, Bryce. Still love saying your name, man. Theodore. Charlie. But let me, a couple things newsworthy. Hogs Gone Wild is coming up this month. We'll be in Silver Dollar Motorsports Park in Georgia. I see in Reynolds, Georgia, it's going to be the Hogs Gone Wild of season's opener. We're going to be presenting it, Star Racing. I'll be there. I'm coming to hang out and visit with you guys and see if we can help promote this Harley-Davidson bagger drag racing. And it's not going to be just Harleys. It's not going to be just baggers. That's the main focus of the sport. That's where the heroes are, and the stars that Roger is trying to promote and build this class. And I think it's our second or third year in a row we've been trying to do it. Hey, Bruce. And I just wanted to share with you guys that what's going to be neat about it is this will be the first time in 2021 we've all been able to get together and start our season off, and it's going to be a lot of fun at Silver Dollar Motorsports Park in Reynolds, Georgia. And I think it's February 26th, 27th. I think they'll run on Friday, and then the main event is on Saturday. And it's going to be a lot of fun. I look forward to seeing you. Thank you, Charlie, for the loud and clear. Appreciate you. But anyway, a couple other things I want to tell you newsworthy is all of us saw, if you follow motorcycle drag racing and professional motorcycle drag racing, you saw that that the three-time champion Angèle Sampey got an opportunity to race again. She's near and dear to us because we started with her back in when she first came on the scene. I think it was in 96 and 97 when she came through our school and started racing. And she was able to win 3 consecutive championships, which was really hard to do back in the day when Dave Schultz and John Myers and Matt Hines were out there racing. And it was tough competition, man. There was 25, 30 guys entered, and it was tough to win races, and that was really cool. But it's great to see her get a chance again with corporate sponsorship and a really fast Suzuki coming up with the new Vance and Hines 4-valve deal, which I know I've spent my life trying to outrun those guys. But look, I'm not racing it anymore, but I'm a fan. I'm a fan of how much our sport, how much attention our sport gets, and I still love motorcycle drag racing and pro stock, NHRA pro stock racing, and I love the Harley drag racing. So I just wanted to share with you guys that this thing is, it doesn't look like it's nosing over it all like a dyno sheet. It looks like it's continuing to grow, and I'm proud to see it and thankful to watch it. The other thing I wanted to share with you guys is Mark Fricke and I think it's called now V-Twin Power Sports near Chicago. I'll let them come on and do their own ad and their own press release and introduce their deal. But I want to tell you the news about it is Mark Fricke and Nancy came in, and Michael, they came in and bought the equipment from Star Racing, and they installed the cylinder head, the SERTI machine, the cylinder head equipment, the flow bench, the mill and the lathe and stuff that Ron used when he worked at Star Racing for 35 years. And they put that stuff in, they installed it in at Ron's house in Georgia there, right there next to America. So it's still it's in Leslie, Georgia. And he is still going to be doing that work at the same rate and at the same style that we did at Star Racing all these years. Same guy, same work. So please support Mark and Nancy and Michael Fricke through V-Twin Power Sports, and also please support Ron, who has carried the flag, kept him in the back, kept him kind of under wraps. He was a behind-the-scenes hero to help us win all those championships and win a bunch of races, and he's still doing it. So I wanted to share that with everybody to know now it's February 2021. There's been a lot of stuff going on. But look, George and Jackie Bryce are in Tennessee, and we are developing Milwaukee 8 performance parts. We're going to market them through all of our friends that are watching. There's a lot of big engine builders that use our stuff, and we want to supply the engine builder with some really great parts so you can make the Milwaukee 8s faster. So given the time that I have now, bandwidth that I didn't have when I was trying to run the business, run the shop, run the racing team, and focusing on my own motorcycle and trying to get everybody else's work done and keep people gainfully employed, it actually clogged up my ability to keep inventing and new ideas and coming up with better camshafts, better valves, better valve train components. So I want to share that with you guys, that's happening. Now, the story real quick before we change over to Tech Talk number 80. I want to tell you the story. I hope you can hear me with the guy with a leaf blower blowing next door. Anyway, back in, let's see when it was, we were running, 1985, John Myers was riding this motorcycle, 84, and we had a friend that worked at Ford Motor Company in Detroit, and he was racing NHRA also, but he was running in a sportsman class, and I'm not going to throw him under the bus or talk about him too much, even though he is an unsung hero like Ron. But this guy had access to a piece of equipment that cost $15,000 in 1985, and it was measure air-fuel ratio in the exhaust, and it was made by NTK, and it was a box that looked like a big transformer, and it had one sensor, and the sensor that screwed in the exhaust pipe cost $5,000, and this box was $15,000. And there's another engine builder in Indiana, his name's Steve Schmidt, and he and I would share this thing with the guys at Ford. And my friend would ship it to me next day air. We would have an engine on the dyno and ready to run it, and it would show the air-fuel ratio with our electron carburetors. It would show if we were lean or rich, and that piece of equipment was $15,000, and it was way over our head. Look, y'all don't understand. Think about when 1985, all right, that's 95, 05, 15, that's 35 years ago. We had a real wideband sensor, and nobody knew about it, nobody heard about it, they weren't available, nobody even, it was crazy. So we were at the shop one day, and we were dynoing, and we were testing with that part, and it was so awesome to see what the air-fuel ratio was, carbureted, how at low RPM, when you'd floor the engine at low RPM, it would be so lean that you couldn't put enough fuel there, and then the carburetor would go so rich at high RPM that we couldn't take enough fuel away to make the horsepower. So we were always working an average. So what we did was we kept shopping and shopping and shopping, and we found a company that would sell us one sensor with one box LED readout from rich to lean, or lean to rich. It would have yellow lights all the way to red lights, and go through, and it would show you a really nice bar graph, but you couldn't look at it while you were going down the racetrack. So we were trying to figure out how to put some kind of camera on John Myers' motorcycle so we could look at the air-fuel ratio, and I called my buddy, Ron Armstrong, when they were just getting going good with the race pack. Before they got, 35 years ago, Ron Armstrong was working there. I told him what I was doing. He was really great keeping secrets. He didn't tell me what anybody else was doing, and he didn't tell anybody what I was doing, and he helped me connect a conversion box to take the voltage output. This is easy to do today. You buy you a new Max ECU now, and with Steve Nichols, and you can take voltage outputs from any sensor, and he can convert it into a graph. He can convert it into numerical data, and he can show you live what it's doing. Well, back then this was unheard of. So he helped me put it on and put a race pack computer on the motorcycle where we could actually see a graph. And it wasn't air fuel, it was voltage. It would show 2 volts, 3 volts, 4 volts, 5 volts, going up and down the track, the volts. And then we had to take that voltage and turn it into our opinion of what an air-fuel ratio based on dyno information. So what was cool about that is when we figured out how to put it on the motorcycle, this box, this NTK box was, I don't know, looked like an amplifier goes in the trunk of your car for a stereo system. And we put it in the bottom of John's, we put the first bottom on the motorcycle, an aluminum pan under the bottom of the motorcycle. And then we put this under the frame rails and put an aluminum panel on top of it and put Zeus buttons on it and painted it flat black so that you couldn't see this box. And we kept diverting everybody's attention to somewhere else on the motorcycle, but we had hidden on the back side of the exhaust pipe, we had an O2 sensor back there, and we told everybody it was an MSD O2 sensor, which it was. That's what it looked like, because you could buy the MSD when we put it on the dash, and it would have a red light and a green light, red, green, red, green. What that one sensor was that MSD sold was a narrowband, and all it did was say on, off, on, off, on, off. So John Myers would be going down the track, and back in the day, we had the first onboard camera with the TV people, and John had the camera on. You could see it on the bike, and it was red, green, red, green, red, green, and it was showing air fuel, but it wasn't showing air fuel. It was showing lean rich, lean rich, lean rich. So it wasn't giving us the data we wanted, so we had to go deeper and find. And one day we were at Reading, Pennsylvania, and Jim Yates came over. He had the McDonald's car, whatever year. It might have been 93, 94, 95. I don't remember exactly what year it was, but he had the McDonald's Firebird. And we were just BSing and hanging out. And he says, "What's that?" And I said, "Oh, man, you can't tell nobody." He says, "Well, what is it?" I said, "You can't tell nobody." So he went back over to his pit. And Richard Maskin was over there. So Richard comes over, and he's a big, burly guy. And also, he's not like just he's not a social superstar, he's just a big guy that has a lot of presence. And he came over and he said, "Show me what you're hiding." And I said, "Can't do it. It's a secret. We can't share it with anybody." And he said, "Well, I'll share something with you if you share that with me." And I said, "I'm interested." So we started an exchange program where we not work together. That's the wrong story. But we started sharing information with each other. And I told him, I said, he said, "I want 8 of those for Jim's car." I said, "Okay, they're very heavy and very expensive, and they cost $7,500 a piece now." So that would be $7,500 times 8 just to put them on his car. Well, it wasn't none of my business. I don't know what they did with it, but it was a really cool story back then. And they ended up running 8 O2 sensors. We ended up running 5 wide bands. We had number 1, number 2, number 3, number 4, and then we had number 5 in the collector. And that was kind of redundant, but what we learned was we had an average like everybody. When you go to the NHRA races now or go to some of the pro stock motorcycle or car races, you'll see they have an O2 sensor in the collector, and that gives them an average of what's coming through that collector. There's 2 lean cylinders, 2 rich cylinders, and whatever that average is what you read in that collector. So that didn't help much, but it could show cylinders had different air-fuel curves, and that wouldn't help you tune very well back in the day. Now with fuel injection, EFI, and push-button tuning, big difference. Oh, I had to put some zero weight in there. It was starting to get locked up. I don't know if it's really zero weight, but it's really lightweight. But anyway, that's enough of that story. It was cool. We were able to hide it and keep it for a little while till it became a little bit more publicly known. And then there's more stories like that because everybody that won a lot always had their little advantage. And being able to read O2s and real-time air-fuel ratios early in the game was an advantage for us, so we could make our electron carburetors work so good. Even Paul Gass would send his carburetors every now and then for us to dyno so we could establish what a good air-fuel ratio curve looked like versus RPM and throttle. And he was able to create a lot of, him and Kevin came up with some really neat little nozzles to go in to add fuel at different RPMs and stuff. So good time. All right, I'm going to flip over to the board now so we can do some tech talk. I hope that was okay for me telling that long story. I didn't want to tell it that long, but there it is. Anyway, the name of that sensor was NTK, okay? NTK was the company that made those sensors, and then, of course, other companies. Now Bosch has got really nice ones, and all the different companies have them out there for sale where you and I can buy some really nice Bosch O2 sensors now that give us real-time in a real narrow band, a narrow range between 10 and 15 to 1, and we can learn how to tune according to that. All right, zero weight. Yep, I'm glad you caught that, but that's what I'm putting down my neck right now, some good zero weight. It's got a stoichiometric of 0 or 1, I think it is. No, centistoke, not stoichiometric. How about that for another redundant term? Centistoke. One of you guys is going to learn to help me look up words like that. All right, I want to talk about the data that we all make decisions on our engines for a minute. I know we have flow bench data, and when you talk to somebody, you call somebody on the phone, I read the ads, I see them all over the internet, I see all the car cylinder heads, Brodix and AFR, and I see the guys at Airflow Research and Dart, and there's some really great companies sell car heads out there, and they talk about what the intake flows, and then they may list an exhaust flow number, but nobody calls up and says, "Hey George, what is your exhaust flow?" So this the reason I put 99 and 1 is this is reference to what we hear, read about, learn about, and what we think we know, include me. because the flow bench is fairly accepted as a good piece of data that the industry uses to how much air goes in the engine. It's a flawed piece of data in my opinion because the piston's going up and down 100 times a second on your flow bench. You turn it on, you put the valve at full lift, 200 lift, 300, 500, 600, 800 lift, whatever you put the valve, and you have a steady stream of air coming in, and the flow bench adjusts to the 28 inches of depression, and then over a little period of time, it will say it flows 320 CFM. But it's not relative because it only flows 320 CFM for 1 nanosecond at full lift, and at 6,000 RPM, the piston's going like this. So when the piston's going up and down really fast, the flow bench can't duplicate what that's doing. And then the exhaust, it's sonic. I mean, it's sonic. It's going, the flow bench can flow 28 inches, 10 inches, or maybe 50 inches with a really good one, but that's not what happens in the exhaust. The exhaust is an explosion in a bomb chamber. It goes bam, and then the valve opens, and this unbelievable pressure flies out of that valve. So this is a totally irrelevant number that people tell you about. Make sure you got radius seats on your exhaust. Make sure you got this percentage on the port, and you got this tulip shape, and you got all that stuff. Those are not my opinion, because if I was the little guy with a spacesuit on and I went in and got in there and watched it on the flow bench, I would see the exhaust coming out at 28 inches depression at full lift, and it would be coming out really nice, and it would love that little shape so it could bend around that valve, and it would love that little tulip on the valve so that it could show how that air turns around that corner. But in reality, it would look like the opening gate, like a gate valve on a bomb chamber. Boom! 8,000 PSI or whatever. Open the ball valve and bam! It blows out. So the flow bench is totally irrelevant of what's going on in there. And if you any of you ever blew an exhaust gasket on your Harley or your street car? I remember on my street car, when I would go really fast, I had exhaust gaskets. I couldn't keep them on there. People asked me, said, well, your headers are too big. And I'm like, well, why is it blowing gaskets off of the head? There's so much pressure inside my exhaust pipe that it tries to come out sideways where the flange bolts onto the head. And on our Pro Stock bikes, we had 2 3/4 pipes. We had 2-inch 750 pipes on our Pro Stocks, big V-twin, and you put some RTV and a little asbestos gasket around there, and the thing was only 20-something inches long. And when you would go down the track, it would blow the gasket out between the head and the pipe because it was a stopper. It was holding it up. So I'm just not a big fan of that whole story there about what this teaches us. So now, I'm going to lower this so I can get down here. What that teaches us, in my opinion, once we learn this and we accept this data, there's not much exhaust data and there's a lot of intake data, but the intake is only one way. So how do you make intake valve closing decisions, exhaust valve opening decisions, intake valve opening decisions, and exhaust valve closing decisions based on this data? It's really hard to get some good stuff, okay? And the reason it's hard to get good stuff right here is because this is skewed or kind of, I think it's poor data. I think it's bad data. What you really want is performance improvements. You want the flow bench. People say, well, what do your heads flow? And I say, at what lift? Well, at 600. Okay, at what depression? 10 inches, 20 inches, 25 inches, 28 inches. By then, I've probably lost them. And I'd be like, he's so smart, but he wants to just confuse me. No, I want to know why you want to know what the heads flow. They flow a lot. They got a big valve. The port's opened as big as it can be. And if you don't have enough velocity, then you got the wrong cam timing. That's my opinion. The piston's going up and down 100 times a second. What are you looking for in velocity? I mean, it's coming backwards. It's going in. It's coming backwards. It's coming in and it's blowing backwards. And the intake port, y'all, it's going in and out like this 100 times a second. So if you don't have enough velocity, you're opening the valves and closing the valves at the wrong time, and you're running the wrong RPM. My opinion. Intake valve closing. All right, now on my camshafts that we sell for the Milwaukee 8s, they come from decades of learning all the wrong things based on this information, based on the internet, based on the sheets that come with the camshafts that tell you all the timing numbers. If you buy a camshaft based on what you read on the internet and something says if your heads flow 320, you got to close the intake valve by a certain number right here. Now, don't let me confuse you with these numbers, 40, 40, 10, and 10. These are percentages of importance, in my opinion. Not your opinion, not Joe Cylinder Head opinion, not the guy that ports your head's opinion, not the guru that internets up everything about his opinions. That's all mine are. That's just my opinion. I'm interneting up to everybody. The intake valve closes. The closure of this intake valve is 40% of everything you need to know about designing a camshaft, in my opinion, to suit your engine based on your performance and the RPM range that you want the engine to run. The second most important one is the exhaust valve open, and it's 40% important also, in my opinion. The intake valve opening is the third most important event, and it is 10%, which is really wrong. It's about 5% of what really matters. And the fourth one is a pretty good tie between third and fourth. They're both last place. This is very, very important. This is very, very important. And these two right here are a good toss-up. The only reason you have these at all is to keep the valve from hitting the piston at TDC or overlap. And that's another story for another day. But I put 10 to be kind. 10% of the information required to design a good program. All right. Why is this one important? Well, your piston's going down one of those 100 times, or maybe it's 50 times on the intake stroke and 50 times on the power stroke, adds 100 times that down on a one power stroke. I mean, the 4 strokes of the engine. I tell it every week. Intake, compression, power, and exhaust. It takes 4 strokes. You got to open the intake valve, you got to close the intake valve, you got to open the exhaust valve, you got to close the exhaust valve. And those 4 events, notice there's no lobe centers here, there's no separation angles, there's no duration mentioned. That's what they want to know. What's my separation angle? What's the duration? And my cylinder head guy says I need this number to be 68, or I need this number to be 72. And I got to know the compression ratio, I got to know the head flow, and I got to know the intake valve closing before I buy your camshaft. Okay? I'm sorry, that's just something that was taught to us on the internet by the people that believe it, just like me. I believe what I'm talking about here. And I'm cool. I am so good with what you believe. And if you tuned in here to watch what I believe, it's going to start off right here. And then it trickles off into the gifts of time and opportunity that I've had to learn these things. And now I want to share them with you because I was taught over my years to share. And I want to share what I think I know. Not the gospel about this. It's just what I think I know. So, intake valve closing is very important. Exhaust valve open is very important. When the intake valve opens is not important to me, and when the exhaust valve closes is not important to me. So if you can understand from all these things, the overlap is not as big as importance as it used to be, because back in the day, overlap was, I think Ed Inskidarian, great man, smart guy, innovator, pioneer, said he used it as the 5th stroke of the 4-stroke engine. Well, that was great for 4,000 RPM Studebakers and flatheads, and you couldn't even buy anything but an Offenhauser with 3 Strombergs and a header that only had 3 pipes out the side of a V8 on each side. I'm telling you, man, that's all they had. They had to focus on that kind of stuff. But now we can get any flow we want, any bore size, any piston, any ring, any stroke. We can do things that those guys back in the Smoky days and before Grumpy days, it was all stuff you buy from Chevrolet, Ford, Chrysler, and there wasn't, Crane and Comp Cams and Isky and some of those other cool companies had some cool stuff. But y'all, the dinosaurs were cool too, and I ain't bagging on. I love the fact we had some cool dinosaurs in our history. And I'm not saying anybody was a dinosaur. I'm just giving you my opinion. Times and things change, and this is where I think I am right now. So, intake valve closing. It traps the mixture on one of the times the piston goes up and down. Exhaust valve open is important because it tells the cylinder when to bleed that pressure off. That matters. Intake valve opening doesn't really matter as much because the intake valve opening just starts this to let the air come in, the air and fuel come in so you can close it at the right time. It's got to start sometime, but when it finishes is 100 times more important than when it starts, in my opinion. It's before TDC. I'm cool with that. but it's not a lot before TDC, because if it opens a lot before TDC, you're going to end up with the valve running into the piston that's still coming up on the exhaust stroke. And then the fourth most important one is, when does the exhaust valve close? Well, you got to get it closed before too much of this comes in. You got to get this closed before too much of this comes in. So I'm cool if you have this opening 20 before and this closing 20 after. That gives you 40 degrees of overlap. That's great at some RPM, and I'm going to say that again. If you have 40 degrees overlap, that's when the intake valve is open and when the exhaust valve is open, and they're both open for 40 degrees of duration out of a 720 degree intake, compression, power, and exhaust. If it's during those little 40 degrees of the 720 deal, that's fine. But it's that important compared to these, in my opinion. All right, just about out of time. But I wanted to give some props to NTK for their coming up with those really cool laboratory-grade sensors that they had back in the day. And I want to please tell everybody about Hogs Gone Wild. I want to share that with you. And I also want to tell you about the NHRA stuff. Is very cool watching how the Vance and Hines story evolves. I was like Ford versus Chevy with those guys for my whole life. Jackie and I spent our whole life trying to beat those guys, but I'm not racing. So I'm a fan of who's getting after it and doing it. And it'd be fun to watch how that deal unfolds during the year. And you guys on here that are racing in that category, God bless you, man. That's some crazy stuff, watching the struggles you go through, dealing with the fuel rule changes, the cubic inch changes, the weight changes, body work changes, and who gets what and who can't have what. And I've got some great stories to tell you about that one day, but I'm not going to complain about it, because I am so thankful that I lived through it. I did a lot wrong, I did a lot right, but I learned a lot, and I'm thankful to share it with you. May God bless y'all. And look, take care of each other. I'm proud for Tom Brady, too, for coming up with his old age. Makes the old guys proud for a minute. Anyway, I'm not going to talk about football. I love y'all. Thank y'all. God bless.